We are focused on really harvesting solar energy. We convert the solar energy into solar electricity, and we use the solar electricity to drive our high temperature chemical process to produce syngas and then liquefy the syngas into synthetic fuel.
Welcome to Sustainability in the Air, the world's first podcast dedicated to sustainable aviation. I'm your host, Shashank Nigam, the CEO of Simplifying. On this show, I speak with aviation leaders, innovators, and policymakers driving real action, separating the signal from the noise to spotlight what's truly moving the industry forward. The same focus that is at the heart of our new book, Sustainability in the Air, Volume 2. In it, Dirk Singer and I take stock of how far the industry has come and how far we still need to go. With the global carbon budget potentially running out by 2032, the clock is ticking. But the most promising solutions today aren't just environmentally sound, they are economically superior as well. From SAF and contrail mitigation to direct air capture, the book offers a practical roadmap for aviation's journey to net zero. Get your copy today. Link in the show notes. My guest today is Philip Furler, co-founder and CEO of Synhelion, a company turning solar energy into synthetic drop-in fuels for aviation. Synhelion is operating the world's first industrial solar fuel plant, producing SAF-ready synthetic fuels that can flow through existing refinery and airport infrastructure. In this episode, Philip explains how solar fuels work, why drop-in compatibility is critical for aviation scale-up, and what it will take to drive costs down from first-of-a-kind plants to truly commercial volumes. Philip, welcome to the show. We finally have you after almost having you on almost a year ago. So great to be speaking. Tell us about Synhelion. What in the world is solar fuel?
Thank you very much for inviting me, and true pleasure to speak with you in this great podcast. So solar fuels, it's quite simple. Solar fuels are made with solar energy. that's the fundamental aspect. So we use solar energy to drive the chemistry for the production of synthetic fuels.
So aren't all fuels solar fuels then?
I mean,
Some
basically,
just take
yes.
a million years or a few
True.
million years.
True. So the energy, most of the energy comes from the sun. Some is nuclear, where you can argue. But yes, primarily we are focused on really harvesting solar energy. We convert the solar energy into solar electricity, and we use the solar electricity to drive our high temperature chemical process to produce syngas and then liquefy the syngas into synthetic fuels.
How is this different from just using solar panels or PVs to generate electricity and then heat? Is this anything different?
No, this is exactly the same. So we use green electricity, which we turn into high temperature process heat, and the heat then drives the chemistry to convert biogas, water and CO2 into syngas, which is then liquefied with Fischer-Tropsch or methanol synthesis into the synthetic fuels.
Right. And you currently have a facility up and running in Germany, is that right?
Yes, we have our industrial demonstration plant Dawn in operation in Germany. We inaugurated the plant 1 year ago, mid of 2024. We took it online in about 2 months, and now it's running for more than a year at nameplate capacity, so at design point. So we are very happy about that.
Very nice. And my understanding is that, Dawn, you have multiple pathways to getting to solar fuel. You have your solar PVs, you've got an electric heater. Why do you have these multiple pathways?
Correct. So we are by DNA a technology company. So we combine quite a lot of technology. and also different pathways for producing sustainable fuels. We emerged from ETH Zurich in 2016, so let's say we developed quite advanced technology, which we over time adapted to really the market needs, and also we established a system which we can rapidly scale now in the next couple of years. So this is what we are doing now with Dawn and what we are scaling up by to large scales over the next couple of years. In parallel, we are still continuing to develop next generation technologies. For example, also concentrated solar, which was our origin basically. So generating high temperature heat using concentrators, so mirrors that track the sunlight and concentrate the sunlight to the top of the tower. So using that concentrated sunlight to drive the chemistry. But this was the origin. It's still a technology which we are scaling up, which we are developing, and which has a very high potential in the future because it's much more efficient and therefore achieves the lowest fuel production cost in perspective, so long term. Nevertheless, it's a technology which needs to be scaled up by factors of 300 or something like that over the next years. So there is significant technology scale-up risk involved, and that's why we are focusing on mature pathways commercially, which we can rapidly scale over the next couple of years. And then on the side, mature, more advanced technology, which then eventually result in further cost reduction or efficiency gains.
Right, that's interesting because you first came to my attention based on those mirrors generating really high temperature at this facility, at the Dawn facility. Now, this plant in Germany is described as the world's first industrial solar fuel facility. You said it's operating to capacity. What sort of performance data are you tracking? And how does that indicate industrial readiness? What's needed?
So we track all kinds of data. So basically, along the process chain, we track all data regarding energy and mass stream. So we track everything, we analyze everything. On one hand, for customers to bring in full transparency, for us really to understand how the technology is performing and how it can be improved. So the plant has a capacity of around 110 norm cubic meters of syngas. So that's very technical. If you would liquefy all the syngas into Fischer-Tropsch product, you will end up with a bit more than 100,000 liters of liquid products per year. So we are running the plant at full syngas capacity 24 hours a day in 4 shifts actually. But we are liquefying only about 10% of the syngas into liquid Fischer-Tropsch products at the moment. And we use those, let's say, demo batches to establish the value chains with our key customers to really understand how we need to arrange it, how we need to implement business models with our customers, and also we are doing the certification of the products and the process.
So are these ASTM certified, RFNBO certified? What's coming out of this facility?
So exactly. So this is what we are certifying at the moment. The process yields 2 products, basically, an RFNBO and an advanced biofuel. And the reason for that is we have 2 energy input streams. One is solar energy or solar electricity, or in other words, renewable electricity, which goes in the process. And then the other energy input comes from the biogas, which enters the process. So about half of the products are RFNBO, great, because half of the energy comes from renewable electricity, and half of the products are advanced biofuel grade because half of the energy comes from
Right.
bioenergy.
And for those listeners who may not be familiar, especially outside of Europe, what is RFNBO and why is this so important?
An RFNBO is a renewable fuel of non-biological origin, which has quite a big importance here in Europe because we see those types of fuels are especially scalable and sustainable. So therefore, the regulator in Europe has implemented a sub-mandate for those types of fuels and let's say, stimulates the supply for those products additionally. For us as suppliers, we expect quite high prices for those products and are therefore keen that we can provide them to the market. But I would say in particular, those products are especially scalable and sustainable. And are based on advanced technology, which needs some support now in the scale-up phase.
Got it. And there's something else I want to dive into. You mentioned that the plant is currently only producing 10% fuel. Why is that? Why don't you just go all the way up?
So Dawn is an industrial demonstration plant. So we use it to demonstrate the technology at the relevant industrial scale. We use it to gain the operational experience, to collect operating hours, and to establish the value chains. But it's not a commercial plant yet. So with about 100 tons of production capacity per year, or a bit more than 100,000 liters, it's way too small to be an attractive business case. And the liquefaction of the syngas is not our core technology. Our core is really around syngas production. So generating heat, storing the heat, providing the heat for the chemistry, producing syngas, that's our core IP, our technology. And the liquefaction of the syngas is not our core technology. We implement it with partners, and therefore we saved some capex now with our first industrial demonstration.
That was the other thing I found interesting, your partnerships. I think they're very innovative, specifically one with Inerotech. How does that work? Is that the partnership you're talking about here?
Yes, yes, correct. So we believe in partnerships along the value chain. So we have several partnerships on the technology side. You mentioned Inerotech. It's a very important one for us for the downstream part. So conversion of the syngas into Fischer-Tropsch products. We implemented, so we added the Inerotech Fischer-Tropsch unit at Dawn. So now we tested it for 1 year. It works perfectly fine. And we also share the same spirit with Inerotech of a scale-up company scaling up jointly. We have very complementary technology, and that's what we try to leverage together. Both have skin in the game, so we continue working together. But we also work with other technology partners like Eni, the Italian oil and gas company, with whom we are developing some processes, but who could also be a licensee of our technology in the future, could be the owner and operator of the future plants, but also companies like the SMS Group, a big steel plant manufacturer, is developing with us the storage technology, the thermal storage technology we have included in our processes. So we believe in partnerships along the value chain. Try to accumulate as much momentum as we can for this scale-up effort.
I love it. And I love the partnerships I've been hearing about and the research that they came up with as well. Ultimately, you're aiming for full drop-in compatibility, right? Do you think this is the decisive advantage when it comes to aviation?
Absolutely. And I think not only aviation, I would say transportation in general. Drop-in fuels have such a huge advantage that they can be used with the existing infrastructure for, let's say, for refining, distribution, but also consumption. So this means you can start small. You can start with the first barrel. And then you bring another 1,000, and then you bring millions or billions of those barrels, and you replace completely fossil fuels. So this gradual ramp up of capacity is, I would say, is the winner. Is much as a huge advantage over other technologies that require step changes.
Love it. Well, talking about barrels, I recently saw you were rolling a barrel down an airport tarmac with the CEO of Swiss Airlines.
Yeah, correct.
Now, that was firstly fantastic marketing. So please tell your marketing team, great job on that. Now, was this a symbolic milestone where you just had some, 3 drops of solar fuel in their jet fuel blend? Or was this a proper commercial proof on. I'm curious to hear what actually you learned flying solar fuel with Swiss.
It was both actually, but it was most of all it was hard work. So this was a couple of years' work, which you have seen there. So it meant we needed to build a whole plant that produces synthetic drop-in fuel. So we produced a barrel of synthetic crude oil, which we provided into a refinery in northern Germany, which is then supplying the airport of Hamburg, and thereby Lufthansa and Swiss. And we needed to figure out all the regulatory aspects as well. So it was certainly also marketing, but for us it was much more important because we figured out a way, a value chain, a commercial model, how we will supply Lufthansa and Swiss international airlines in the future commercially. That's much more than just marketing.
Yeah, no, I completely hear you because you're just producing neat SAF. Ultimately, this neat SAF needs to be transported, blended, gotten to an airport, and put in the wing, right? What was the biggest challenge in this entire value chain? Was it the blending? Was it the transportation? Was it finding an off-taker like Lufthansa or Swiss?
All of them, I would say. But exactly. So that's the point of Dawn. So we have now the capability. We are producing fuels, and now we are establishing with our customers the best and most efficient way of supplying them in the future, and we establish win-win business models with them. And this might look different for a customer in the, let's say, for an airline customer. Could be different for the private jet market, is different if we are supplying, let's say, a road customer in Switzerland, for example. So with each of those customers and with each segment, we try to really understand it. For an airline, the way we figured out with Lufthansa and Swiss international airlines is the following. So we are producing a synthetic crude oil in our plant, which we provide into a refinery in the network of Lufthansa and Swiss International Airline, which then provides the jet fuel to the airport. So we are not supplying the neat SAF into the airplanes of Swiss, but we are providing the synthetic crude oil into the refinery. So this means we are really making use of the existing infrastructure. We leave everything like it is. We are not replacing anything, but we are simply replacing fossil crude oil with sustainable synthetic crude oil. And the only thing you need to do is to build the plant.
Right, got
That's
it.
it.
So then did you have to approach this fuel supplier for blending it, or did Lufthansa Swiss connect you? Like, here's the guy you talk to, this is who you deal with.
So the synthetic crude oil is directly injected into the crude oil mix of the refinery. So it's not even separated. It's co-processed with the crude oil and thereby replaces one-to-one a barrel of fossil crude oil. So this is in the end then a mass balanced system. So you never go
Got
to
it.
the neat SAF. We arrive with the neat synthetic crude oil, but then it's really provided into the input stream of the refinery.
Got it. Got it.
And this
Very
might look different for different customers. With Lufthansa, with Lufthansa and Swiss, that's the way to go. And we are now rolling it out step by step to be a commercial product, and might look different for other customers.
makes complete sense. Now, what is the total life cycle emission reductions that you're targeting from your fuels?
So for Dawn, it's at least 85%. And we went through the exercise also with an independent third party validating our life cycle emission, and this was even above 90%. So we can go very far. At least our processes yield a product with 85% greenhouse gas reduction compared to the fossil reference value.
Wow, that is very, very impressive. But my understanding is that this typically comes at a price, a significant what's called green premium. So I'm wondering how you expect this green premium to reduce over time, because do you intend to replace electrolysis with the heat concentration mirrors that we were talking about, which you say is lower cost? Is there Are there other factors that will make solar fuels as competitive as fossil kerosene?
Yes, correct. So we have some fundamental advantages. One is we use a very cheap renewable energy input. Solar energy combined with thermal energy storage results in a super cheap, continuous 24-hour a day renewable energy input in the process. Second, we are not using electrolysis, so we are preventing the utilization of green hydrogen. We don't need green hydrogen, which makes it much cheaper. And then we have a very high energy conversion efficiency of over 90% in this process. So we can run it continuously with thermal energy storage. We don't need green hydrogen. And we have a very high energy conversion efficiency, which results in very attractive fuel production cost. Having said that, very important factor is the scale. So at the small scales we are now at 100 tons per annum or 1,000 tons per annum, this is way too small to be competitive. So we need to scale up to large size, and this is the strongest cost reduction driver. So we target now in the next step a plant with 1,000 tons of production volume. It's a commercial pilot plant. And in parallel, we are preparing a larger scale plant at the 30,000 ton scale and one at the 100,000 ton scale. So we will come down rapidly with costs, and we long-term approach values of around €1 per liter of production cost, so $1 of production cost, which we believe is low enough in order to be integrated in the business models of airlines and so on, and will not impact significantly the ticket prices.
Wow. When do you think you'll reach this $1 cost? This is amazing.
I would say we will reach that in about 10 years, 10 to 15 years from now.
So I have a question. When you approach airlines, right? What is the early mover advantage here? Because it seems like there's an early mover disadvantage that an airline is going to pay a lot right now, but if they follow 10 years later, they'll get this really low price thanks to the other airlines that tried and tested it. Do you ever get this pushback?
That's certainly let's say not an early adopter disadvantage. We don't want to frame it like that, but it needs pioneering spirit to step in now and to help scale up this production capacity and this technology. So the way we put it is the ones that help us scale now will have an advantage in the future. So one is definitely if you help us now to scale, as many pioneering customers are doing, they get now the marketing attention and they get access to the larger fuel volumes during our scale-up phase. So this will be limited. So we go now to 1,000 tons. It's a commercial pilot. We are actually sold out until 2032. So we have signed binding offtake agreements at the significant premium. And those that signed those offtake contracts will get preferential access to the large-scale volumes coming online 2030. Exactly at the time when the regulation kicks in and the sub-mandates for RFNBOs and so on will be activated. So this is the way we put it. If you help us now, you will get an advantage. And we believe the market will be short in the future. So it's
Right.
I think a wise step to move forward now.
Right. Well explained. I threw you a curveball, and I think you did pretty well on that.
Thank you.
You mentioned scale up, right? I believe your first commercial plant in Germany will have 1,000 tons of annual production. That's many-fold increase compared to the current one, and that's I think by 2027. So, what's required in terms of policy, pricing, demand for that timeline to hold for those volumes to be reached?
We are completing now the feed phase, and we expect the FID in the first half of 2026. So what we need now is clarity on the funding side. So we requested quite a significant amount of governmental funding for this project, which then, if we get it, will result in an attractive business case, which we believe we can convince some of our investors to finance this plan. So it's basically the financing which needs to happen now the next half a year, and then will realize this plant. So the offtake, as mentioned, is already signed, binding for the first 5 years.
That's very, very encouraging, actually, that you have already started looking at volumes from there itself. Now, I know we talked about you rolling a barrel of solar fuel on the tarmac, but you also drove a rather fancy car in the Swiss Alps, which was powered by solar fuels. And it's not just aircraft systems; it's a motorcycle, a heritage steamboat, a car. You've been doing a lot of pilots. Are these just engineering tests? Are these public awareness moments? What are these? Tell us a little about this fancy life you live for a e-fuel producer.
Thank you. Those are cool cases, but the 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 fundamental aspect is we cannot only produce jet fuel. So we are focused on SAF and jet fuel, and we trigger our processes to yield the maximum of SAF. So we have about 70% or so of our products is actually SAF, but we have also other products like diesel and naphtha, gasoline and some others for which we need to find off-takers, and luckily we have plenty of off-takers also for those other products. So we also produce diesel. We have the airport of Zurich buying diesel for the buses. We have a marine company operating historic steamboats. So it's really a beautiful case. We have even a mountain resort operating the snow groomer, or a construction company using the diesel for the construction machine. And we have the biggest car importer in Switzerland that signed a long-term offtake agreement for sustainable gasoline. So we are exploring with AMAG how to integrate sustainable gasoline into their business model, into cars. And with the CEO of AMAG, I drove a historic Audi Quattro Sport in the Swiss Alps against Ferraris and Lamborghinis. So this was really cool. And the solar fuel did perform as expected.
I love it. Yes, that was a pretty cool video and demonstration. Now, you've focused squarely on transportation. Why the focus on transportation? Why don't you just make waxes for L'Oreal, for example, using e-fuel? Why are you focused on decarbonizing all forms of transportation?
That's our mission from the beginning. So we want to contribute towards a better world. So this was our mission from our early days in research to contribute to a better system. When we went forward, we clearly understood aviation is really our core market. It has no alternatives than using sustainable kerosene for the next decades, from my point of view. But also the other parts. There are other parts in transportation, like marine and parts on the road, which will rely to a certain extent still on sustainable fuels. So why not providing them the solution as well? And for us, from a business perspective, we again try to align as much momentum or partners and customers as we can to support this scale-up mission. So the more markets we can serve, the more customers we have, and the more support we can accumulate for the scale-up roadmap. So it's actually a plus that we can serve not only aviation, but also the other markets as well. And you mentioned L'Oreal. This is certainly something what we are also exploring. I mean, providing some of our products into the chemical or pharmaceutical industry is also interesting, and might stabilize even the business case.
Yeah, that's amazing,
or make
right?
it more attractive.
Right, because there are multiple takers for the product, not just one, for example.
Exactly.
And their demand is also going to come at different times. Now, you've stated an ambition to reach 1 million tons of solar fuel annually in the next 10 years. How are you going to get there? And what's the single biggest risk that you see in achieving the target?
So how we get there, it's an exponential scale up, which we're planning. So we go a factor of 10 now to the next plant in Germany. Then we go another factor of 30 to the next plant, which we will have on the ground until 2030. So a 30,000 ton plant per annum. And this is then the technology at the full scale, and then it's multiplied. So those trains are then multiplied into even bigger plants. So yes, we are scaling up exponentially, um, which is possible because the fundamental technology blocks are now validated at the industrial scale and implemented with large industrial partners that provide those components and can provide them at, let's say, a couple of hundred times a bigger scale. So for us, for me, the biggest risk now is not on the technology side. This is an engineering challenge which we can solve with our partners, with EPCs and so on. It's more on the financing side, on the market side. We need to find the right financing structures to make this happen. And this is what we are really focusing on at the moment, besides all the technology scale-up stuff.
That's amazing, Philip. In your journey till now, you said it started from ETH and now to a pretty successful company, scale-up company. What have been some of the big moments you as a founder have been really proud of? Getting here must have not been easy.
Yeah, there were some challenges involved, definitely. I would say I'm most proud of the team which we established over the year. We are now about 70, so 70 FTEs, half of the team in Germany, half of the team in Switzerland.
Wow.
We onboarded many experts from different industries, for example, oil and gas, and have now really a strong and well-working international team that is ready for this massive scale up. And then certainly another highlight was the inauguration of Plant Dawn, and now seeing how this plant, which was built on time, in budget, and in function, is now really operating as we have designed it. So we debugged now, so we operate this plant over 1 year. We debugged many things, and now it's really working in 4 shifts, 24 hours. This is really something new for us. It's really working like a proper industrial scale plant. So this is really rewarding to see the team
Amazing.
succeeding like.
What's also unique about Synhelion is you're a Swiss technology company. Yeah, I think Switzerland doesn't have the space to build lots of SAF plants. So a lot of your growth will be global. What's unique about being a Swiss company here trying to go global? Are you trying to license plants, make a lot of fuel? How are you approaching this in a different way?
Very good point. So I think the positive thing of being in Switzerland is we have excellent research institutions. So ETH Zurich is among the 10 top universities in the world. So we have top research and we have lots of research funding. So this generates, let's say, the starting point for scale-ups. And then, so we took it out of ETH in 2020. In 2016, we collaborated from the beginning very closely with the German Aerospace Center and the colleagues there. We acquired by the end of 2021 a startup from the DLR, which is today Synhelion Germany, so the German branch. So I think we profit heavily both in Switzerland and in Germany from the very top-notch research, and now we are scaling up long term. So now we are in a role of a fuel producer. So we develop the project, we develop the technology, we build the plant, we operate the plant, we sell the fuel. So we do everything at the moment, not because we love to do everything on our own, but we have to. So we need to demonstrate that the technology and the plants are operating as expected, and that we can generate the profits and which we expect. So we need to demonstrate the business case, the viability of the business case. And then once this is done, we intend to move into a licensing model. So we scale up now until around 30,000 tons until 2030. We have the technology at the full scale in the market, demonstrating attractive returns. on the plant level, but also for us at the top company level. And then we moved back into, let's say, a project developer role. We provide the key components and we provide technology licenses to large energy and oil and gas companies that we see in the position as plant owner and operators long term. I don't believe we can contribute much in this game, owning and operating large assets. Oil and gas industry is doing that for 100 years. I think we cannot contribute, but we are really strong in developing technology. And this is also coming back to the beginning of the interview. This is also why we are on the side developing the next generation technology like concentrated solar, advanced catalysts, and so on, because we need to drive this further. We need to improve further, and we bring this technology then later on to the market. Further reduce cost and increase efficiency.
I love this entire storyline, how it was the ETH startup spun off, collaborated with someone in Germany, brought this technology to life. Now you're still collaborating, not just within aviation, but in the entire transport sector. And, you're hitting the milestones. I love that Dawn is in full production and you've got 100x scale up, then the 300x scale up, 10x scale up. All of those are coming. So really excited to see what's coming, and congratulations and getting this far.
Thank you.
The final round of this, final part of this interview, I'm sure you've heard before, is called the rapid fire round, in which we get to know you, Philip, a little bit more personally, and have simple questions like, what's your favorite airline?
That's an easy one. Swiss International Airlines. As
Okay,
a Swiss and with Swiss as our key partner, so that's an easy one.
What about your favorite airport?
It's also Zurich Airport. It's maybe a bit, but it's true. I love Zurich Airport.
Can you be a little less Swiss and be a bit more unpredictable now? I know the Swiss love to be predictable.
I will.
Okay, favorite city?
Hong Kong.
Okay, good. Now we're getting started. See, it's first two questions for just warm up, you see.
Yeah, that's perfect.
Favorite movie?
That's a difficult one. Maybe it's hard to nail down one. Maybe it's Goldfinger.
Oh, James Bond.
James Bond. Yeah.
Okay, all right. You're a
Probably
Bond fan.
James Bond. Yeah.
How about favorite book?
It's also difficult. I read many books, maybe 30 or so per year. So I don't have one. I can name you one, which my favorite book in 2025 was from Philip Bloom. Is an author that I have met on stage once, a philosopher, and he wrote a book which is called The Nightmare: How the Little Ice Age Changed the World. Which is quite fascinating. So he described how the ice age, let's say the climate change during the ice age of a couple of degrees less, changed society, and now he extrapolates how this global warming could change society again. But this was a very, very interesting
good one. I shall pick it up. I've heard of the book. I've not had a chance to read it, but I will definitely take your recommendation.
And he's also a very nice person.
I'm glad you met him. And what do you do in your free time, Philip?
I do a lot of sports, so cycling, running, gym, and also most important, I have a family. I have 3 kids, so I spend most of the time with my kids now in winter in the mountains, skiing.
Okay, that's good to hear. I don't know
kids, family, and sports.
Okay, and what is something you'd like to learn?
So related to that, when I'm cycling with my kids, I'm trying for quite a while to do a proper wheelie with the mountain bike. It's pretty difficult, but I would like to do proper wheelies. And maybe next summer I will be successful. I hope so.
Yeah, I think right now is the time for skiing. So next season.
Now's the time. True.
Finally, what's the best advice you've received?
Just do it.
Just do it. Well,
just
Philip,
make the first step and do it. Start it. Yeah, that was the best advice.
Get rolling. Love it. Well, this was a great chat, Philip. I'm glad we finally managed to do it. Thank you so much for the answers and joining me. And congratulations on all the progress you've been making. I think solar fuels is a story that aviation needs to hear, and I'm happy that we were able to get this out.
Thank you very much for the nice conversation, and looking forward to having you at the plant, showing you the plant.
I cannot wait.
Yes.
Thank you so much for the invite. I'd love to visit.
Thank you very much. Thank you.
Thank you. Thank you for listening to this episode of Sustainability in the Air. Aviation is one of the hardest to decarbonize industries, yet there are multiple paths to get to net zero. Awareness is key to a green future. So please give us your support to help our sustainable aviation insights reach a wider audience. You can do this by sharing this episode on your network, on LinkedIn, Twitter, or even WhatsApp. Or perhaps you might consider leaving a review on Apple Podcasts, Spotify, or wherever you listen to this episode. You can start a conversation with us by writing to us at podcast@simpliflying, that's simply with an i.com. And for more content on sustainable aviation, please visit our website green.simpliflying.com and join the movement. Sustainability in the Air is an original podcast by Simpliflying. The show is produced by Juraj Toth in Slovakia. Dirk Singer is our Director of Sustainability, who leads research for each interviewee out of Greenwich, UK. Shubhadeep Pau is our Supervising Editor based out of Mumbai and Singapore. The articles are written by Ayushi Badola in Dehradun in India and Meera Hull in Montreal, Quebec. Creative design is led by Ligia Esteve in Montreal. Baiba Drimen is the project director for the show based out of Valencia, Spain. Special thanks to Wendy Sim in Singapore. And I'm Shashank Nigam, the CEO of Simpliflying and your host. Please feel free to connect with me on LinkedIn.